Bismillah. My dear respected instructors, I would like to greet you and welcome you to my Master of Engineering presentation. My name is Muhammad Tatar. I'm a graduate student in Engineering Management degree. My master project involves the use of Six Sigma methodology to improve pharmaceutical warehouse productivity process and reduce order mistakes. We will not be only using Six Sigma, but also various project management tools represented in systematic layout planning and design. In this presentation, we'll cover the following headlines. First, we'll go through a brief introduction, and then we'll explain the role of literature review in our project. Next, we'll cover the methodology process used in solving several project issues, and finally, we'll discuss the project results, findings, and conclusions. So, as we go through the introduction, I would like to give a slight background about myself. I have worked in a pharmaceutical company in a distribution warehouse as operations supervisor. This company, alhamdulillah, it's expanding each month, and I always aim to apply my skills and knowledge in supply chain management and use different concepts learned in engineering management and system engineering to solve real-life business problems in my field. This project aims to find applicable ways to be implemented in my industrial field to help meeting my company's goals and objectives. So we'll talk about the significance of this project. Why is this project important? This project will provide an insight to efficient use of quality tools and project management techniques applied in supply chain management system to help in the reduction of order mistakes and to boost the productivity process, which is actually a very challenging task for businesses to achieve high standards of internal supply chain processes, keeping cost at its lowest. Next, we'll talk about the need for this project, the need identification. Basically, the need is describing current situation which is unsatisfactory. Here's our need. As the company's business is growing, the current operational system doesn't conform to the standards and requirements of effective facilities planning and design. So we believe there's a big misusage of space and energy and material handling inside the warehouse, and we can do better than this in order to achieve our goals. And next, we'll talk about the project goals and objectives and constraints. So the project goals, we have developed them after carefully defining our business processes and studying our internal and external customers and knowing their needs and requirements, as we will explain later in the coming slides, in the coming project slides. So the project goals are as follows: to maximize the production volume, to reduce order mistakes, and to improve work efficiency and process flow. As for the objectives, we have stated they are to effectively determine the placement of all facilities, to improve material handling, material control, and housekeeping, to effectively utilize people, equipment, space, and energy, to promote the flexibility and ease of maintenance, and to promote employees' safety and job satisfaction. For our project constraints, we have met with the top management, with operation management, after we have decided to improve the layout design of the warehouse, as we will describe later in the slides, in the methodology phase. And so our operation management, since we have sat with them, we decided that the following project constraints should be taken into account before we implement any improvement changes to the current layout of the warehouse. The first constraint is that the system departments should be rectangular or square. And second, the budget for the system implementation should not exceed 20 million reals. And then the most important departments, of course, should be near each other. And the next constraint is that the warehouses should be environmentally friendly. And the last constraint is that the aisles should be at least 30% of the area of the plant to allow for better movement inside the warehouse. Okay, so we have finished from the introduction phase, and now we will discuss important literature review concepts that were very helpful for us to study and analyze and come up with excellent implementation tools and techniques throughout this project. And they were very helpful for us to identify and solve several problems that we have faced. So in this literature review, we'll discuss two important engineering management concepts used in this project. First is the Six Sigma methodology, where we will discuss the meaning and importance of Six Sigma and how to effectively apply its tools to achieve major improvements in our project. Second, we'll cover the topic of project management and how to implement its tools in the facility layout planning process in order to solve the issues of inefficient space usage at the workplace, which has led to poor process flow and bad material handling. So moving to the first topic, which is the Six Sigma. What is the Six Sigma? Six Sigma is a project-driven management approach to improve the goods, facilities, and processes of the company by constantly reducing organizational deficiencies. So Six Sigma is a continuous improvement process. In statistics, Six Sigma is a quality improvement system with the goal of reducing the number of defects to 3.4 parts per million opportunities. The sigma itself is a Greek letter, and it's a statistical unit of measurement used to describe population standard deviation. So it tests the distribution of the data around the mean. Okay, as we can see here in the normal distribution curve, which is bell-shaped curve, and the mean is at the center of at the peak of the curve. The data lying inside the lower specification limits and the upper specification limits are the acceptable range of data. It's lying inside these ranges, or the yield. And the data points lying outside of these range limits, they are the defectives of the process. We'll talk about also the sigma standard. So, as presented in the below graph, and we can see in the table that the larger the number of sigma, the lower the number of defects, and the higher is the process yield, since most of the data points will be lying close to the mean, or within the acceptable ranges. Motorola has described the Six Sigma as the zero defects because it has only 3.4 defects per million products. So reaching Six Sigma is a very tough process indeed, and requires lots of steps and lots of hard work. Now we'll talk about Six Sigma methodology. So the Six Sigma uses standard improvement method called the DMAIC method, D-M-A-I-C method. D stands for define, M for measure, A analyze, I improve, and C control. So we'll describe each of these methods here in the coming slides. The define phase is related to knowing the customer's voice, building SIPOC diagram, which is to analyze the business by knowing its suppliers, input, processing, outputs, and customers, to develop and understand the process flow of the business, and to make process mapping. In the measure phase, we are mainly concerned about collecting data collection and planning, to study the baseline data, and to measure the process actual performance. And here we can also use descriptive histograms and charts. The analyze phase, we do brainstormings to come up with the root causes of our problems. And then, of course, we identify the root problem factors, and we make a relationship diagram between the cause and effect of these root causes. And we make also a risk analysis diagram. Risk analysis diagram is very important. It gives the descriptive influence scales of different root causes affecting the current process. The next phase is the improvement phase. This phase is about removing the deficiencies and mitigating the damage. Here we can use the systematic layout planning method, and it uses the project management tools in defining, evaluating, and picking the best alternatives. And of course, implementing the best picked solution, as we will discuss later throughout the methodology phase of the project. So last phase of the DMAIC process is the control phase. The control phase ensures the continuity in the process improvement. It ensures that the main variables are kept within the stated control limits, and introduces new practices, procedures, and corrective measures. So the next topic we'll discuss is the facility layout. And the facility layout is organizing the physical structures inside the building or facility in such a way to allow the optimal flow of materials at the minimum cost with the smallest amount of material handling. Okay, so now we go to the different types of layout. in the facility layout. We have different types of layout in the facility layout, but we will here state the four main types, which are the fixed position layout, where the components are fixed, but tools or machines are moving around these components. And this is suitable for just several orders, bulky products, and variable demand. The next layout is a process layout, where the equipments performing common functions are grouped together. And this is suitable for processes having continuous change of product and variable demand also. The cellular layout involves grouping into families based on common machining requirements, which is like a loop, basically, placing the machines in like a loop-wise. And the last type of layout, which is the main layout, which we'll use in this project, it's the product layout. The product layout, we basically place the operations or the departments immediately adjacent to each other, immediately after each other, next to each other. This can be used for mass production, and it's used also for stable demand processes and continuous supply. This layout is used currently in our pharmaceutical warehouse, and we will use the same layout as well to come up with a better alternative design for our warehouse design. Okay, so now we'll talk about the facility layout problems. Facility layout problems, they can be single objective or multiple objectives. The multiple objective ones, they have either conflicting objectives like minimizing the total flow cost and optimizing the total closeness ranking and security, or congruent objectives, which are similar objectives, like minimizing the distance weighted costs like the flow rate, closeness rating, and hazardous movement, and etc. So let's move to the systematic layout planning. Okay. Basically, the systematic layout planning is made to enhance the productivity and space usage inside the facility and an operation unit. The SLP technique provides good results in enhancing workflow during the production process. It uses the concepts of project management tools, such as data analysis and collection, looking into possible alternatives, evaluating alternatives and selecting the best alternative, and such, and implementing the best solution. As well as we use the FLAP software, which is the facility layout program software, to help us in the systematic layout planning process, to help us come with the different alternatives of the new design of the warehouse. This software is very basic and easy to understand and easy to use, and gives good results amongst many other softwares. So let's move to the data collection and analysis process. We can gather here technical information of our process. We can do market research and come up with market research findings. We will use a tool such as the quality function deployment tool, which translates the customer requirements and needs into engineering requirements. Okay, and the halves of quality here in the diagram, it helps us in the quality function deployment method. It helps us to identify the customer requirements and interrelate them with the engineering requirements, as well as it makes a correlation matrix between the engineering requirements themselves. It relates the engineering requirements to each other, how they affect each other. And it uses benchmarking as well to compare the current design with other similar designs. There's also a prioritized requirements section in the bottom, which informs us about the importance level of the customer requirements compared to the remaining customer requirements. And next, we'll look into possible design alternatives in the systematic layout planning process. So looking into possible alternatives, first we come up with engineering design specifications or product specifications. These specifications, they represent a set of requirements that are targeted for the design. We also recommend different material handling techniques for our operational work process to improve the work process. Material handling, of course, is the science involved in moving packaging and storing of substances in any form. It affects the building requirement, department arrangement, and production time. Later, after specifying I don't know how to say it. After specifying the material handling techniques, we can generate the alternatives using the FLAP software. The FLAP software will come up with the two alternative designs as the best solution, as we will see in the coming slide later in the FLAP software how it works. Before that, we'll go into the evaluation, the manual evaluation of the alternatives, and how we can make a concept into selecting the best alternatives among these alternatives generated with the FLAP software. So the evaluation process, we can use descriptive scales and numerical scales. We can use pairwise comparison method, as we later also in the methodology phase describe it. The pairwise method, as it assigns values to the cells and computes critical criteria totals, and then it gets a normalized weight for the equivalent criteria. We have also another method which is PUG's modified concept. This concept is also very important, where it creates a set of criteria options, and they are scored and added up to achieve total score, and then can be ranked also afterwards. And it involves also the idea of weighting the criteria. The last and most important evaluation method, of course, is the cost to benefit analysis. This method is very effective, and it measures the advantages and disadvantages of alternatives. And we can see which alternatives offer the best solution and gives the most benefits while maintaining the savings and giving the least costs. So the cost-benefit analysis is represented, of course, in monetary values, and they are calculated for the time value of money, the net present value of money. The net present value as formula is given as below, which is the total benefits minus the costs over 1 plus the risk percentage to the power of time. And after calculating all the net present values, we measure the BCR, or the benefit to cost ratio, where if we see that if the benefits weight exceeds the costs weight, so if there's a high benefits to cost ratio, it means that we go for this alternative design. We select this one. So we measure the different alternative designs, and we come up with their benefit to cost ratio, and whichever design gives us the highest ratio, we go for it because it gives us the most benefit weight. So next, we'll discuss the FLAP software, of course. This software, what it does, it uses a matrix of activity relationships or department trips to determine the facility layout. So between each department, we enter the importance of one department to another, of one department and its link to another department, or the importance of one department into being next to the other department. So we use letters, basically. A stands for absolutely necessary, absolutely important. E stands for essentially important. I stands for important. O stands for ordinarily important. And U stands for unimportant. So as we can see in an example here, the relationship between distance between Department 1 and Department 2 is absolutely important. Between Department 1 and Department 3 is important. Between Department 1 and Department 4 is essentially important, and so on. This is just an example. And the FLAP software takes this concept into arranging the departments in such a way to minimize the cost and we achieve our goal. It also gives it a scoring criteria. It gives a scoring, relying on a scoring model for each of the layout. So giving the best solutions or the best alternative layout for our facility. Okay, and it also determines, of course, the closest ranking between the departments and their selection order. Okay, so getting done with the literature review, we would like to move to the methodology phase of this project. We would like to note that all the tools used in this project, of course, are in light of the Six Sigma DMIC methodology combined with the systematic layout planning techniques. So using DMIC phase 1, we come up with these methods. We have designed customer satisfaction survey, and we have made a SIPOC diagram for our operational warehouse. We have also developed process flow chart of the work, and we made process mapping inside the warehouse. So the customer satisfaction survey, of course, are a reliable data point for recognizing customer voice. A very impactful survey should be very efficient and should have measurable goals. As you can see in the survey here, we have conducted for more than 500 pharmacies, and we gained more than 200 replies from them that our customers are basically not happy about the production volume of the warehouse. They're not happy about the support in urgent orders and complementary orders. They're also not happy about the mistakes. They aren't satisfied with the order mistakes, about their communication with the store to resolve the problem of order mistakes. So basically, with our customers, these are the main two problems that we have to try and solving. The increasing the production volume and reducing order mistakes. And this is how we came up with the idea of this project, and to use the Six Sigma methodology trying to achieve this goal. So the SIPOC diagram, of course, is a method that company uses to define all important elements before beginning the work. So we define the business method of working. We identify suppliers, input, process, output, and customers. As we can see here, we have the operational warehouse has many suppliers, the top management, product suppliers, governmental relations, human resources, freight forwards, different inputs in the system and in the floor and stuff. But we are mainly concerned about the products, about the materials, which the order pickers are picking the items, the medicine items, as per the pharmacy orders, and they are delivering to the pharmacies. Here we have a problem at this point, where there's basically the orders fulfillment is not full. There is a lack of productivity. The orders are too big, and we cannot match the order size. And the order mistakes, of course, are very high, and we try to reduce the order mistakes. So we'll look into the second cell here, which states the suppliers, product suppliers, input products, process receiving of goods and goods put away in goods store. This is the process that we are trying now to work on. Output, fulfillment, customer requirements. Customers are clients, of course, pharmacies and retail shops. But mainly the medicine warehouse has the customer as the pharmacies. Then the cosmetics section or distribution section of our company, which is another warehouse, they are mainly concerned with the clients, different clients and retailers. Okay, so moving to the process flow chart. The process flow chart is an analysis tool that maps process through a collection of structured flow chart symbols and stages. This is the flow chart we have come up with. So basically, we have stated the detailed process, that we measured the duration time of it. We put the symbol and description of the symbol, of course, the description of the process. So, like for example, receiving a shipment, one trailer takes around 33 minutes. The receiving process, inspecting it, the supplied shipment takes 18 minutes, moving the shipment to open storage area, 24 minutes, and so on. And the picking process, of course, is considered to be as the picking process to fill one truck, which is the order size of 12 pallets. Each pallet depends, containing around 20 to 30 boxes. We measure the picking process to be around more than 2 hours, a bit, 132 minutes for one truck. We ship around 12 to 15 trucks a day from the warehouse. The loading process takes, for one truck, takes about 18 minutes. So basically, this is the process flow of the warehouse. We'll try also to aim to reduce the process flow and save time, hopefully. Okay, so this is the process mapping, where we can recognize the main areas of strengths and limitations, and we can see which processes they consume lots of time, and we can minimize the cycle times. As we can see here that the inspection for mistakes, actually we are trying to cut this process and include it with the packaging process. So the inspection for mistakes after the order pickers are picking the items. We have made here, our department is, there's like one full department for inspection for mistakes, and there's lots of wastage of time. Later in the report, I will describe how we can remove this task of inspecting for mistakes, and combine it with the department of packaging. So there will be packaging and inspection at the same time. We'll discuss later how we have managed, or how we'll try to manage to improve this process map. Okay, this is define phase. We are done with it. The measure phase is, of course, we collect the actual data. So we calculated the daily productivity report of the laborers for 1 month, and we measured the total mistakes to prepared line of items. We made mistakes distribution graph to see the distribution of mistakes, and we came up with the performance chart, and we measured the current performance using the Six Sigma method. So this is the daily productivity report, which shows us the prepared line of items of the laborers. It shows us also the output rate of the prepared line of items according to the order size. Of course, when the order size is big, then the prepared line of items will be more. But since our system is not optimal, the efficiency of the workers does not cover up for the big order size. And the mistakes, of course, mistakes number is very high. We have specified here the mistakes as shortages and excess mistakes. So basically the line of item can either be short in the preparation process. We can have shortage in the prepared line of item, or mistakes in the prepared line of item. So since this is independent of each other, we stated that the observations for these for each mistake is independent of the other one. So one line of item can either have shortage mistakes or excess mistakes. Hence, in 30 days, we have come up with 60 observations. Okay, as the following regarding the mistakes, shortages, and excesses. This is, of course, the mistakes to prepared line of items ratio. As we can see, as the work pressure gets high, the laborers tend to make more order mistakes. It's a human error. It's a natural process. Distribution graph, which is showing the distribution of shortage and order mistakes in the graph. So we have set our limits to be the ranges for mistakes, minus 50 for item shortages and plus 50 for the items excesses. Any mistakes in this range of mistakes will be acceptable, as long as the laborers do not make shortage mistakes above 50 or excess mistakes. This is the performance chart, where we can see lots of data, like around 22 observations are outside of our range limits. They are considered as process defects. This is a big number. So here we measure the current performance using Six Sigma, where we can see that the calculated mean is -4, around -4 mistakes per day. It's the mean of normal distribution. So this is the average mistakes the warehouse makes per day, -4 mistakes. Okay, the variance was calculated to be 2,720, and the standard deviation is around 52. And by calculating the z-score of the lower specification limit and the upper specification limit, we can find sigma level to be around 2 sigma level, 1.917, which yields 65.5. So 65.5% of the data lies in the acceptable range. and the rest sadly is outside the range, which is the process defects, and this is a high number, and we're aiming to improve this process. So moving on to phase 3, which is analyze phase. Okay, so we try to come up with root causes and remove the root causes and such, and we bring the team's attention to the issue. We use the fishbone diagram, risk analysis diagram, and Pareto chart. The fishbone diagram, as we can see, it's cause and effect diagram, which measures the root causes and of different processes. Here we measured the root causes, problems happening in the supplier side, process side, man, environment, machine, and material, as described here. After brainstorming process with the top management, we have sat with them and we have decided that these are the possible root causes of our problems, leading to low productivity and high number of mistakes. Okay, and we analyze it using risk analysis diagram. Okay, so the diagram here below shows the causes and their likability and severity, and we calculate, of course, the RPN value and the impact of these causes on our work. We can see that the manual order picking process, random replenishment of items, because laborers tend to randomly replenish items. When any bin is empty, they just go and put items in it. This creates lots of order mistakes, and it's a random process really, that even most of the items are placed on the floor, and this is very bad for the work. It causes slow movement and lots of order mistakes. Manual picking, of course, is dependent of the manual pick, or dependent of the labor, which are humans and tend to make more mistakes than machines. And of course, the small workspace, it's not actually small, but it's not used properly. So the workspace, I mean, we are already, we can consider the movement to a bigger warehouse, but we are also willing to change the layout size of the layout design of the current warehouse. We can just change the layout design and improve. This will improve the productivity process and the production of the warehouse in general, the movement and the material handling and stuff. So anyways, we'll work on this process. After deciding, of course, the RPN value, which are very high for these three factors, we can see from the Pareto chart presentation that, you know, the 20% of the causes, they cause the most of the problems. It's quite clear here from the graph that the first three root causes, the small workspace or the bad usage of workspace, random replenishment of items, the manual order picking, they are causing most of the problems here, and we'd like to address these problems and solve them as our main factors. So, moving on to the next stage, which is the improvement stage, that is to define, evaluate, and pick the best solutions. We will use the systematic layout planning, of course, here. So we have data collection analysis, looking into possible alternatives, and evaluation and design selection. In the data collection analysis step, we have technical information. We have gathered technical information, which is regarding the warehouse dimensions and area. As follows, we have stated the departments. Each department, what is it for? So department 1 is for inspection of goods, department of received goods, and department 2 is the supplied goods storage area. Department 3 is the order preparation place, where the preparation takes place of the items. Department 4 is the inspection for mistakes of the order picked items. Department 5 is the shipment. Packaging is for the packaging of the prepared goods. Department 6 is the final storage area, and Department 7 is the offices area. So we have 7 departments. This is the current layout of the 7 departments inside the warehouse. There's a bit of misorganization in placement of departments. And basically here we would like to remove the inspection department and combine it with the packaging department and increase the area for the production department. So we will aim to move area department number 4 with 5, and department 3 and 4 we combine them together to make it one big production area. We will also separate Class A items from Class B and C items. The Class A items are fast-moving items. So Class A items, they will be moved into separate area in order to enhance the productivity process and not to waste too much time walking between the aisles. The Class A items mostly move in bulk quantities, so it's better for them to be placed alone, and they can be, transported very fast and packaged very fast. We will aim also to increase the size of the inspection area and the storage area of the supplied goods, as we expect lots of supplied goods in the coming period. And we can see that the department of the offices, they have big areas, so we'll cut from their space as well to add them up to different other departments of the warehouse. It's better to cut also from the offices area of the supervisors and managers, as they have already agreed to that. Okay, so we developed the house of quality here, where we list the customer requirements. So the house of quality basically describes the customer requirements, which are the requirements of our internal customers inside the warehouse, the middle management, the top management, the laborers, which is as follows: to minimize the distance between departments, improve material handling, material control, minimize capital investment. The layout should have easy maintenance, should be safe, friendly for workers in the workplace, friendly environment, good looking, and fair satisfaction, and maximize production volume. And these are the engineering requirements we have set also here. So we look how the customer requirements are affecting the engineering requirements, which customer requirements belongs to which engineering requirement. We have also set the importance weight for each of the requirements. The next matrix, it shows the interaction between the engineering requirements themselves, how each engineering requirement affects the other. So in distance between departments, it affects the cost and the capacity. Okay, and such and such. I mean, we have come up with these after we sat with the management and decided on how we can enter these interaction matrix. And so when we look into possible design alternatives, we of course set the engineering design specifications, which are as follows. The intended market is the pharmaceutical company. Maintenance cost is about 300,000 reals. Operating environment, of course, since they are medicine items, between 18 to 24 degrees. Okay, so these are the engineering design specifications to consider before coming up with our new design layout. Of course, we determine the relationship chart between departments to enter it into a flap system. So this determines the placement of the departments in the flap software to come up with the best design alternative. So department 1 is very important, absolutely important to be placed next to department 2. They are basically placed in sequence as a product layout. Okay. So the flap software generates for us these two tables: the closeness ranking of the departments and the selection order. The alternatives generated by flap software are as follows: one which is a rectangular layout and one which is more of square layout. One layout it has two docks instead of one docking system divided into two for loading and receiving. Okay, so we would like to evaluate these two alternatives, and before we evaluate them, we will talk about the material handling techniques. Of course, we have suggested using the mobility devices in order picking. This will reduce order mistakes. The mobility device will scan the item before picking the item, and we'll also use barcode system to put it on the bins. So the order picker will scan both the bin and the item, and this will greatly reduce the order mistakes, because basically the item's placement even will be correct once we use the mobility system as well in the replenishment process. The items will be placed in their correct bins instead of randomly placing items in different bins or placing the items on the floors. We will also use the apron conveyors to move the items in the warehouse. This will provide a fast way of items movement inside the warehouse, items transportation inside the warehouse. And we can use also the last figure here. It shows the forklift for the picking of pallets and storing them, whether in high places or low places. So these three tools or machines, they are very important material handling techniques that we will use for our new design alternative layout and for our new process of production. So in order to evaluate the alternatives, we register the score 51, for example, for the first alternative and 41 for the second alternative. The material handling techniques, they can be different, whether to use apron conveyors and forklifts inside the warehouse, or forklifts and order trolleys, or we make it a total conveyors system, automated system. The picking system can be either mobility, using mobility devices and manual picking, or only manual picking, or total mobility picking. The packing system, fully manual, automated, and such and such. The maintenance type can be manual, also automatic. So we came up with many alternatives. Actually, if we will try to combine these different alternative concepts into alternative designs, and we select the optimum design options we can possibly think of. So design option 1 will have score 51, which will be a total conveyor system. It will have mobility picking and automated wrapping, auto maintenance, shared dock. The design option 2 will have a score of 41, which is set by a flap software. Okay. It will include the use of forklifts and trolleys, mobility picking as well, automated wrapping process, pallet wrapping instead of boxes wrapping, manual maintenance, separate docks, and design option 3, as we can see, score 51, apron conveyors, system and forklifts, manual picking, manual wrapping, auto manual maintenance, and shared dock. Anyways, we evaluate these design alternatives, so we come up with the advantages and disadvantages for each design alternative. The advantages of design 1 is that it's very fast and high quality production process and reduced human errors and human interference, but it's very costly and can be hard to maintain. The design alternative 2, the advantages is that it's not expensive and and very easy actually to maintain because it's manual maintenance. It will improve somewhat the work quality because we're using the mobility system picking and the replenishment system and also automated wrapping. But the disadvantage is that it's not capable to improve the productivity process, which we are aiming to improve. And there's complete human interference, so it increases the risk of order mistakes. It doesn't solve the order mistakes. The design alternative 3, the advantage is that it's satisfactory in the implementation cost. It's easy to maintain than the fully automated system, but the work quality will not improve much, and the work speed will somewhat remain to be as it is. So the productivity will not increase to the desired level. So we evaluate these options based on the descriptive scales and numerical scales as follows. And the numerical scales show clearly that design option 2 is the best amongst 3 alternatives, having total score of 27 in terms of cost, time, quality, and maintainability. These are the criteria. We come up with this criteria in order to meet our goals and objectives of the project, to be included in each design. Okay, so the selection of optimal alternatives using the pairwise comparison method, we set the numbers of 0 and 1 in this method. So basically, number 1, we set it if the left criteria is more important than the criteria on the top. And we come up with the total scores of the criteria and then the normalized weight. Next, we can use also the modified Pugs concept. Okay, so we have the normalized weight and we have the rating, the numerical rating of each alternative, and we calculate the weighted rating, which is to multiply the rating of the alternative with the normalized weight. So for each design alternative, we come up with the total at the bottom, and it shows that alternative 1 has actually a higher rating than alternative 2 and alternative 3. So using the cost-benefit analysis, which is the effective analysis for evaluating any project or any design alternative, we set it over the course of 7 years for each design alternative. Of course, the risk factor here, we have set it to be around 9%. We have estimated an inflation rate at the value of 0.25, increasing by 0.05 every 2 years. So we calculate the cost to benefit ratio at the end after calculating the present values of benefits and the costs. So cost to benefit ratio, here we have the design alternative 1 is showing the highest cost to benefit ratio, more than design alternative 2 and more than design alternative 3. So the cost to benefit analysis tells us to choose design alternative 1 as our optimum design layout to meet our objectives and goals. Later, after the implementation of the preferred design, which is design alternative 1, we will decide on the strategic actions to be taken to ensure the intended results are achieved and they are continuing. We ensure the continuity of the process improvement. We'll discuss the man-related system control, the material-related system control, supplier-related system control, and what is the action plan schedule that we have come up with. So in the man-related system control, it's necessary to hire more laborers at the workplace, and it's necessary to hire high-qualified laborers and conduct lots of training, enough training for them. Clear guidelines of training should be established as well and revised from the top management. The material-related system control, it's recommended to use, of course, advanced machine packing tools to wrap up all the boxes firmly on pallets instead of using the current hand tools like scissors and brown tapes. They will reduce packing errors and include incomplete packaging of boxes or mixing of our boxes with different pharmacies together. Supplier-related control, we would like to have effective communication with the suppliers and we make them committed to the receiving policies we have, and strict actions should be and penalties should be set to prevent any poor commitment. And good forecasting should be made in the next time, in the next period, and lots of safety stock should be kept in the warehouse in order to cover up for any sudden expansion needs from the customers, from the pharmacies. So we expect lots of orders in the coming period, and we should have enough safety stock in the warehouse. After we study, of course, the forecasting in the coming months. Of course, order schedules should be accurately planned, and continuous market research should be made. The action plan schedule is developed as follows by setting responsibilities and target dates for different persons. So we have the risks, causes, and impact. We make recommendations how to solve these problems, root causes, and setting responsibilities and dates. And we make, of course, the action results section, whether the task is done or not yet. Okay, so moving on from methodology, we would like to discuss finally the results and conclusion of the project. The project summary. We have project results and project conclusion. So project summary, we use the DMIC Six Sigma methodology to define, measure, analyze, and improve and control our warehouse process. We used also systematic layout planning and project management techniques involving data collection and analysis, conceptualizing the alternatives, design alternatives evaluations using different methods as we have seen. And finally, we came up with the optimum design selection. So the results are as follows. The expected results, of course, since this design is not yet implemented, but if implemented, the expected results are expected to be as follows. There will be lots of time saving in the process flow. We expect a minimum of 30 to 40% of time saving. Since the inspection area is cancelled, we will have 2 areas for production, fast production. There will be use of mobility devices and apron conveyors, reducing order mistakes. There will be improved flow inside the warehouse. So we expect it to be very time-saving for the process flow. And the production area, of course, as we can see here, no more items without bins, items in the floor. There will be lots of available bins, good area usage efficiency. The bins usage efficiency will be good. So we divided the production area into Class A and Class B items. Class A items is set into production area 3 and production area 4, and production area 3 has Class B and C items. Okay, so there will be increased productivity in the warehouse. We have made a comparison between first quarter of 2020 and first quarter of 2021. Again, minimum of increase of 30% in the order productivity. If in case more labor force is joining us with the highly qualified laborers, we expect more than 50% increase in productivity, which is a very good number. In terms of order mistakes, of course, we can see the mistakes distribution graph. We can see the data points are coming closer to the mean, are lying closer to the mean. Okay, and even the mean itself has improved to be around 2.98, minus 2.98, and the yield of the process is calculated after summing up the Z scores to be around 2.881, which is around 3 sigma level. So we have increased the system process. We have improved the system process by 1 sigma level, which is a very good result. And the yield of the data should be around 92% of the data should be within the acceptable limits. So the order mistakes will decrease, and we will not find lots of order mistakes going out of the acceptable ranges. The reduction of order mistakes will heavily affect the savings of the company, where it's expected at least core savings of around 500,000 riyals, estimated to be 5 million per year of mistake saving. And this is a very big number, very big saving for the company. So we estimated the first quarter of 2021 mistakes report, the sales price, making the sales price of the order mistakes, it will go down, creating lots of savings for our company. So thank you for listening. And in conclusion, as we can see, we have done here in the report, we used the Six Sigma methodology combined with facilities layout planning tools. We came up with different solutions and enhanced the productivity process and the pharmaceutical company. We managed to find ways to reduce order mistakes. And this project has the capability to shift the operational performance by one Sigma level, by one whole Sigma level. We came up with one design alternative to reallocate the warehouse facilities in such a way to optimize the space use and enhance the process flow. Any recommended future work from now is to continuously run quality tests and make good use of Six Sigma tools to continuously evaluate the system's performance. Of course, we will aim to sustain the desired improvement level, and hopefully raise the Sigma levels to higher scales in future, since the Six Sigma methodology has the capability to do that. Thank you for listening, and goodbye.